This chapter begins with three-dimensional coordinate systems. We have worked in two-dimensional systems for years and years. So this is the first time we move into three space. In two space, it's called R2. We call it R2. And in two space, you have an x-axis and a y-axis. And we can do things like graph the point 2, 3. So it would be somewhere about here, the point 2, 3. So that's R2. And now we're moving into R3. So in R3, you have an x-axis and a y-axis, but you also have a z-axis. And it changes what we have. So this is our x-axis here, and it actually comes towards you. The y-axis is the horizontal, and the z-axis goes up. So it's a very different look. I'm going to move this up just a little bit. R3 is our three space. It's defined as the real numbers and the real numbers and the real numbers. So that's the notation before it. It's the product, the Cartesian product. And this equals the set of all values x, y, z such that, let me get some more space here, x, oops, that's not an x, such that x, y, and z are elements of real numbers. So you have a real number in each value. And that's where our R3 notation comes from. So we graph this to be R3. And they call this the right-hand rule. So if you take your fingers and curl your pointer finger and point it towards you, that's your x-axis. This finger that comes, oh, that moves. This finger that comes out here towards you is your x-axis. This is your y-axis where your arm is, and your thumb goes up along the z-axis. So you have your x-axis, your y-axis, and your z-axis. So your right hand, as long as you curve your fingers in and point your pointer finger at you, is a good illustration of the right-hand rule. Now let's talk about a different one. So look at this example here. You can see the x-axis, the y-axis, and the z-axis as we talked about. By the way, this is the left corner of the room, and you can see the floor. You can see the line coming out along the floor towards you is the x-axis. The line going out from the floor to the right is the y-axis, and the line going up into the ceiling is the z-axis. Now, if you're on the second floor, if you think about going down, that would be the negative z. If you think about going back into the other room, instead of coming towards you, going back into the other room, that's negative x. And back to the left instead of the right is negative y. And then these create planes. This plane you can see in the picture here on the right wall, this plane is called the YZ plane. It's one of the planes it's the plane that cuts down through y and z. The one on the floor here is called the XY plane. And the one on the left wall, this green wall over here, is the XZ plane. So the plane is two-dimensional in a three space. So in a two-dimensional graph, we have four quadrants. We have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And in a 3D graph, we have octants because there are 8 spaces. It's the floor, it's above the floor in this room that you can see. And if you kind of think about it, there are octants. That's why there's 8. So this is a slightly prettier picture here. And we're going to get into looking at sketches and graphs and solids and surfaces in 3D, but you need an understanding of what the 3D plane looks like. So let's talk about graphing a point in a 3D plane. In order to do so, first of all, you draw your 3D plane, and then you got to think kind of a box when you do this. It's easiest to do with a pencil. I'm going to start this with a pencil, and we'll see if it can be bright enough to show up. So when we do this, first of all, you need to put marks on it. So normally, when we put marks on our graph, we kind of try to make sure that they're the same spacing. I'm only going to put 3 on the y because I need 3 on the y and 5 on the z. Now, we know that x is on the diagonal of the hypotenuse, so it's a little bit longer. So it's not spaced exactly the same, shorter, longer, something. I only need 2, but I'm going to go ahead and put 5 there. All right, so let's see if we can make this work out in such a way. When we do this, we're going to go 2 spaces on the x-axis, and that's going to be right here. So I'm going to go 2 spaces on the x-axis and 3 spaces on the y-axis and 5 spaces on the z-axis. But when you graph it, it's easiest to do with the pencil. So although the pencil doesn't show up well, we come out here 2 spaces. And then we're going to come out on the y. But when we draw the y, we're going to draw it parallel to the x-axis. So we have a box here. That didn't work too well. Let me try that again. We have a box here where the lines are parallel. Do you see how the lines are parallel? So it kind of gives you a box for the intersection of the two. And if you think about the way that box intersects, that's the way it works on a 2D graph. So if you were to lay this flat, this would be the point of intersection of those 2 graphs. Now we need to go up 5. So I'm going to go up 5 from my y right here. And that would go here. And that's going to then, so that's where those 2 intersect. Now I need to complete my box. So this one's going to run parallel here, about the same length as it is down here. So I'm gonna come out 2 here, gonna come up, and it creates a box. So this point right here is the point of intersection of the point 2, 3, 5. Now it's easy to see that we came over 2. We came out towards us 2. We went to the right 3, and we went up 5. So that's how we achieved that point right there. But you can kind of see it on the box. If you go back to the box, you could fill in the back space. It actually runs right along here. So it runs right along the axis the way I drew it this time. So that's to graph the point 2, 3, 5. Sadly, WebAssign doesn't have you actually graph this point. You should do some on paper so you're comfortable with it. It is one of the hardest things we do. We're not good at art, most of us, because we are very science mathy people. So just do your best. Let's look at one more of these. This one's an interesting one. So I'm going to go ahead and draw my axis, my XYZ axis, and we're going to look at the point 4, 0, -2. So draw your axis, go ahead and attempt it, and then come back. Okay, so we're going to come out 4 on the x-axis. We're actually not moving over to the y-axis. And then we're coming down 2 on the z-axis. So we're going to run these parallel lines. And since it's on the xz plane, that is actually the answer right there. Let me switch and mark it as my answer. This is my answer right here. It's 4, 0, -2. So we came towards this 4. Let me put it this way. We came towards this 4. And then we didn't go up or down any. We didn't go right or left any. And we went down -2. It's actually kind of fun once you get the hang of it. But if you think of it in terms of a parallelogram in the last section, and this is the XZ plane. In this section, it's not too bad. So, G-ish. There are some interesting things to consider. So think about y equals 3. Think about it, first of all, in R2, and then secondly, we're going to think about it in R3. Now, R2 is our 2-dimensional Cartesian coordinate system we used to have. Pause for a second and think about what that is. Hopefully you said that's a horizontal line, y equals 3, and it is. And then if you think about it in R3, what we have is we have a plane, like a piece of paper, that sits right here through this dot, y equals 3. So we tend to draw it very kind of sketchy. So we're going to draw this plane down and kind of shade it in. So it's a piece of paper that runs parallel to the x-axis, and it goes through y equals 3, because it doesn't matter what x and z are. You could have the point here that says 5, 2, 3. You could have the point 0, 0, 3. You could have all kinds of things. We kind of draw it to the side of the axis, but it runs parallel to the x-axis and the y-axis. And the z-axis, and it goes through z equals 3. let's think about x squared plus y squared equals 9. In R2, that's a R with an extra line, and that means the 2D space for all real numbers. In R2, this is a circle with a radius of 3. Now in R3, this becomes a circle around the z-axis as a radius of 3, because z doesn't matter. Z could be anything. This is our x. But we tend to draw it with a stop because we can't draw without. But it keeps continuing infinitely. It's like a right circular cylinder that just keeps going in both directions infinitely. It doesn't have any depth. It's like if you fold a piece of paper around a circle. So it's a really cool picture. I'll pull one from a textbook in a minute. And then let's just change it up just a little bit, because the question is, what happens if you have x squared plus y squared equals 9 and z equals 3? I'm sorry, z equals 3. I didn't write that correctly. And z equals 3. So what we have here is we have the same idea, but z equals 3. That means that right here at z equals 3, I have a circle that goes around it, and it has a radius of 3. So we have a circle that sits right there with the radius of 3. Now we have an even better one. Let's say x squared plus y squared is less than or equal to 1. Well, in that case, what we have is we have a right circular cylinder, but it's filled in. The radius is 1. It's still a circle. The radius is 1, but this is completely filled in. So it's like a can. It's completely filled in. So you can see that the inequality helps us out in that aspect of it. But we make it even more interesting by x squared plus y squared is less than or equal to 1. And let's say that z is between 2 and 6. Inclusive. So what that means is, I forgot to draw my x-axis on this one. Let's go back. My x-axis on this one. So we have, again, a right circular cylinder, but it starts at 2 and it goes up to 6. So it's a can that has a height of 4. That looks like a fun problem. Slight question for you. What happens if you have x squared plus z squared equals 9? Well, in that case, you're going to have a right circular cylinder that sits over the y-axis, and the radius still is 3. Because it doesn't matter what y is, so that right circular cylinder goes over the y-axis. So, all right, let's move on from here. And just thinking for a moment, x squared plus y squared plus z squared equals 9. This would actually be a sphere because you have all 3 variables, so you have all 3 happening. So this is a sphere with the radius of 3. Oh, gracious, to draw a sphere. It's interesting. With the radius of 3. So that goes up 3, out 3. We have 3 in every direction. So the sphere is kind of fun there. We're going to get into more about spheres in a minute, but let's put that on hold and let's talk about the distance formula. The distance formula is going to be used here, so let's go ahead and do it. If you remember the distance formula in 2-space, this is very similar. Remember that we have x, y, and z. So in our distance formula, we're going to say d equals the square root of. In 2-space, we say x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So in 3-space, we're going to do z2 minus z1 quantity squared. The proof of it is very pretty. You go back to a 3D graph right here. Arrows all around. And you're going to pick some point P with x1, y1, z1. And you have another P, which is x2, y2, z2. And remember, there's a parallelogram between them. I'm sorry, a rectangle, a cube, a box. So the distance formula is easy to prove and easy to see, but you could Google it. I'll let you do that. It's an interesting proof. So now the distance formula works the way you think it should. So let's use A and B. So when we pick point A to be 2, -1, 7, and point B to be 1, -3, 5, you can find the distance between them by using the new distance formula that we just did. So we're going to take x2 to be 1 minus x1, 2, quantity squared. By the way, pause this. You can do this without me showing it to you, and then check with me afterwards. Pause. Keep going. All right. And then hopefully you paused it and you have an answer. -3 minus -1 squared plus 5 minus 7 squared. So D equals 1 minus 2 is -1, squared is 1. Plus -3 plus 1 is -2, squared is 4. And 5 minus 7 is 2 squared, which is 4. So we get the square root of 9, which is 3. So the distance between those 2 points in 3 space is not very difficult to find. So it's pretty good. Now, if we use the distance formula, so let's go back to that conversation about the sphere. If you think about a sphere, we have a center, and we can go to a point on the radius. So using the distance formula, we can call the center HKL. Think about the center of a circle, we use HK. So with the sphere, we use the cursive L, and it goes to a point on the outside of the sphere, XYZ. So our distance formula then would be x minus h squared plus y minus k squared plus z minus l squared. And this is equal to the radius. So then if we square both sides, we have x minus h squared plus y minus k squared plus z minus l squared, which equals r squared. So that's where your formula from the sphere comes from. It's really a nice formula to look at. When you do this, your center is at HKL, very similar to what you learned about circles. And then if you have x squared plus y squared plus z squared equals r squared, then your center is at the origin, which is 0, 0, 0. In both cases, your radius is r. So now we're going to talk about spheres for a few minutes. We could we could sketch, but let's describe. Let's describe a sphere that is x minus 3 squared plus y minus 7 squared plus z plus 2 squared equals 18. So it says describe. We're going to go with that because we don't want to have to sketch that point and then sketch the sphere around it, but we could. Let's make it sketch for today. We'll do both. So this means our center is at 3, 7, -2 because we change the signs when we take them out of the parentheses. And the radius is the square root of 18, which in mathematical exactness is 3 square root of 2, but it's actually a little more than 4. So think about the fact that it's 4 point something. So since we said if we said describe, we would say sphere. We left that off with a center at that point, 3, 7, -2, and a radius of the square root of 18, which is 3 times square root of 2. But since we changed the directions to sketch, which you probably won't have to do, I think in WebAssign you just have to match. So what we're going to do is we're going to start off with 3, 7, 2, and we're going to find that point first of all. So let me switch modes. So we're going to go 3, 7. This is way easier to do with a pencil than it is on an iPad, just in case you're curious here. Okay, so I'm going back to my beautiful writing utensil. So if I come out 3 and over 7 and up 2, this is my point right here. That's the point for the center of the sphere. And the center of the sphere now is going out a little more than 4. So we're just going to draw a random circle here and say we got a sphere with a radius of 4. It doesn't have to be exact. It's a sketch, not an exactness. So kind of makes it not really pretty. So often we describe and we don't sketch. Now this gets a little more interesting when it says describe. And the problem says x squared plus y squared plus z squared plus 4x minus 6y plus 2z plus 6 equals 0. So we know it's a sphere. See the x squared plus y squared plus z squared? So we know it's a sphere, but we have to complete the square in order to come up with the circle in the center. So we're going to rearrange these to be x squared plus 4x minus, or plus y squared minus 6y plus z squared plus 2z equals negative 6. So we're going to complete the square, so I'm going to put a blank here because I need to complete the square for the x. X squared plus 4x plus blank plus y squared minus 6y plus something else plus z squared plus 2z plus something else equals, let's see if I can move it over a little bit, negative 6 plus all those values. Okay, short version of completing the square. You can take half of this number and square it. So when I take half of this number and square it, I get 4 in both of these blanks. And then that factors into x plus 2, which is x plus 2 squared. Now, you might start skipping that step at some point. It's okay, but remember that when you do FOIL on these two parentheses, you have to have the 4 up here to make it work. So the trick is, let's go ahead and bring our pluses down. You're going to take half of this number to be negative 3 squared to be 9. So that means this would factor into y minus 3 quantity squared. You can do the step in between if you'd like, y minus 3, y minus 3. We're going to bring the plus down. Hopefully you remember this concept from Calc 2 and Conics. We're going to take half of this number to be 1. Squared is 1. So this factors into z plus 1, which is z plus 1 squared. So let's fill in the rest of the blanks. This one was a 9 and this one was a 1. So we add all those numbers together. We have 1 plus 9 is 10, plus 4 is 14, minus 6 is 8. So if you look at that last line, that's exactly what we need. So when we describe this, we describe it as a sphere. It has a center at negative 2, positive 3, negative 1. And the radius is the square root of 8, which is 2 square root of 2. This one is interesting because it says 2x squared plus 2y squared plus 2z squared minus 2x plus 4y plus 1 equals 0. So when you do this problem, what's really interesting about it is you can never complete the square with the leading coefficient. So with the leading coefficient other than 1. So we're going to divide everything in the whole problem by 2 so that we have a leading coefficient of 1. Can I rearrange things while I'm at it? I better not. So we have x squared plus y squared plus z squared minus x plus 2y plus 1/2 equals 0. I had to pause and make sure I copied the problem correctly. So I'm going to say x squared minus x plus something plus y squared plus 2y plus something else plus z squared. There's no other z, so that's nice. We're only completing the square twice. Equals negative 1/2. We took that to the other side. Plus a blank. Plus whatever the y is. All right, so when we do this problem, there's an understood 1 here. So half of 1 is 1/2. And then squared is 1/4. So I'm going to go ahead and write that in both blanks. And then this is x minus 1/2 times x minus 1/2 because it's whatever we took half of. And if you did FOIL, it does work out. So this is x minus 1/2 squared. Now let's take half of the 2. Half of the 2 squared is 1. So we're going to put a 1 in both blanks. And this factors into y plus 1, which is y plus 1 squared. And then we can just bring down the z squared. That's a nice problem. Now negative 1/2 plus 1/4 makes negative 1/4. Plus 1 is 3/4. So we have 3/4 here. So again, we have a sphere. And the center is 1/2, negative 1, 0. And the radius is the square root of 3 over 4, which we could say is the square root of 3 over 2. So completing the square is a skill. Hopefully it's not too hard. You do have to do some of it, so practice that. Let's look at a couple interesting problems. The problem says find the equation of the sphere with the, so we know we're trying to write a sphere, so keep in mind what that's going to look like. It has a center at 3, negative 1, 6, and it passes through the point 5, 2, 3. Pause for a minute and think about how you're going to do that. So when we do that, we have the center, so we also need the radius. So the radius is going to be the distance between the center and the point. So the radius equals the distance, which is the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared plus z2 minus z1 quantity squared. So we're going to say 5 minus 3 squared plus 2 plus 1 squared plus 3 minus 6 squared. So my radius is the square root, and 5 minus 3 is 2, squared is 4. 2 plus 1 is 3, squared is 9. And 3 minus 6 is negative 3, squared is 9. So that's the square root of 22. So then our sphere is going to be the equation x minus, and we put the center in 3 squared, plus y plus 1 squared, plus z minus 6 squared, and the square root of 22 squared is 22. So that's our sphere. Now there's a couple more interesting ones. Let's look at 2 problems that are going to be similar to your homework. And one of them is easy because they just tell you the center of the sphere and the radius. So that's even easier. But there's 2 problems I'd like to go over before we wrap up this video. Okay, this says describe, and you have a couple inequalities. The first one says 1 is less than or equal to x squared plus y squared plus z squared is less than or equal to 4. So if you look at this in pieces, this part right here means a sphere. And the radius of this part is 2, and the radius of this part is 1. So if you think about a sphere, we could put it on the x, y, z axis, and we probably should. Here I have a radius of 2 for this sphere. And then the inside sphere has a radius of 1. So it's a hollowed out sphere, kind of like a jawbreaker without the middle. So it's a 3D graph. And all of this is solid. So it's a Cadbury egg, only a circle. So it's solid up to a point, and then it's hollow on the inside. So not really a Cadbury egg. So as you can see, this is a radius, a sphere with a radius of 2. And then this is a sphere with a radius of 1. Now let's talk about this part. It says z is less than 0. So that means it's below the z-axis. I'm erasing too low. Let me try again. So it's below the z-axis right here. So now you can see this graph. I'm going to, the sketch, I'm also going to pull it in from the book so you can see it a little more carefully. So you can see how pretty it is when it's actually done in 3D. All right, I think there's only one more we want to talk about before you go do your assignment. It's similar to your homework. So the directions on this one say find the distance from this point. This one's 1, -7.5 to each of the following. I'm not going to do all of them because they make sense. But letter A is the XY plane. So the distance from -175 to the XY plane, we're going to look at it, and then we're going to talk about the distance formula, but we're not going to do that for all of them, just for this one. So 1, -7, 1, 2, 3, 4, 5. All right. Okay, so if you look at this picture, we're looking at this point, 1, -7.5. Now the distance from here to the XY plane. Now remember the XY plane is the plane, it's this one, it's the XY plane. So if you think about this distance is 5 because that's the Z. That's how much we went up. So as you can see, the space down here, this is the XZ plane, and we went up 5 from that. So it's 5 on the XY plane. Now we could do it algebraically. The X and the Y would stay the same. I guess there's a negative there, and we put 0 for Z. And if you use the distance formula, you'd find out for certain that Z was 5. The distance up from the plane was 5. So letter B, let's talk about the distance to the YZ plane. Now, if you look at the fact that X is what didn't move, that distance is 1. So visually, we can see that we came out 1. Right here, we came out 1 from the XZ plane. Let's do one that might not make as much sense as the other ones. So let's do it together. Part D says the distance from there to the x-axis. Now, if you think about the x-axis, what we're doing is we're talking about the point here, the point here. We're talking about all the points on this plane. So the distance from this line. So the distance from there to the x-axis. When we do that, the x is going to stay the same because we want to stay on that value on the x-axis. So the y and the z both become 0. So we're going to look at the distance. So we have, I'm going to do the point we were given minus the x-axis. So 1 minus 1 squared plus -7 minus 0 squared plus 5 minus 0 squared. Hopefully that makes sense. Let me change it just a little bit. So then 1 minus 1 is 0 squared is 0. Plus -7 squared is 49. Plus 5 squared is 25. So this gives us the square root of 74. 74 is 2 times 37, so that does not reduce. That does not simplify. All right, well, I hope you enjoy this section. It's kind of fun. It's kind of easy. The interesting thing about Calc 3 is it's everything you've learned in 3D spaces. So we'll be doing a lot with all of that, and I hope you understand this video. If not, let me know. Have a great day.